Hey everyone! I want to start off this video by saying that the intended audience is students that have already taken Algebra 1. I'm going to be explaining a concept from Algebra 1, factoring, using basic concepts and basic vocabulary from Algebra 1. So if you've never taken an Algebra 1 course, this explanatory video will be a little bit above your understanding. This video will cover what is a quadratic trinomial, what does it mean to factor? And how do you actually factor a quadratic trinomial? So the first question, what is a quadratic trinomial? It is a quadratic with 3 terms. That root tri should make you think of 3. And in case you don't remember what a quadratic is, that's something with an x squared term. So if you see an expression with an x squared term and no higher exponents, that's when you know it's a quadratic. So this is a quadratic because of the x squared term. More specifically, it's a trinomial because it has 1, 2, 3 terms. Similarly, this one is a quadratic because of the x squared term, and it's a trinomial because it has 1, 2, 3 terms. So hopefully that definition of quadratic trinomial makes sense to everybody. Now we can talk about what does it mean to factor a quadratic? It means to rewrite your quadratic as a product of terms. So here's an example of a quadratic in standard form. So this is how you might be used to seeing them. The x squared term comes first, and then the x term, and then the constant term. If I wanted to rewrite this exact quadratic in factored form, it would look like this. So if we go back up to the definition, it says to rewrite your quadratic as a product of terms. That's exactly what I've done here. It's something times something, right? We've rewritten it as one set of parentheses times another set of parentheses. So believe it or not, even though these look totally different, they are equal. It's the same quadratic written in 2 different forms, standard form versus factored form. And one more time, this is factored because it's something times something. It has been rewritten as a product. So I break quadratic trinomials into 2 different types, easy ones and hard ones. So let's talk about what my definition of an easily factored quadratic trinomial is. Easily factored quadratic trinomials are trinomials where the coefficient in front of the x term is 1. So here you can see that visually with a couple of examples. Here's the x squared term, and the invisible coefficient in front of that term is 1. So this would be an easily factored quadratic trinomial. So with this one, there's the x squared term, and there's an invisible 1 in front of it. By contrast, this is an example of a not easily factored quadratic trinomial. Here's our x squared term, and the coefficient in front of it is a 2. So these are hard to factor trinomials, and I'll talk about them later in this video. These are easy to factor quadratic trinomials, and I'm going to start this video by talking about how to factor them. So now that I've talked about what makes something an easy quadratic trinomial to factor, let's talk about the actual steps so that you could factor one. Here they are, and I'll go through this all with an example. Step 1, set up 2 sets of parentheses like this. So x with a big blank space, and then x with a big blank space. Fill in the blank spaces in the parentheses with the magic numbers. And the magic numbers are 2 numbers that multiply to your C term and add to your B term. This might be totally confusing just to read these steps. That is totally okay. I'm going to go through this example step by step, and I think it'll be more clear once you see me working through an example. So step 1, set up your parentheses. All right, it's always going to look like this. An x in parentheses, and then a second set of parentheses with an x, and then we need 2 blank spaces here. And then I talk a lot about magic numbers. That's a Miss Coffin original term. The magic numbers are two numbers that multiply to your C term. This is your C term, the constant term at the end, and add to your B term. Your B term is this term right here, the coefficient in front of the X. So I'll say that one more time. We need to find numbers that multiply to 15 and add to 8. If you're really good at your times tables, you might just be able to come up with this in your head. If you're not, I would highly encourage you to come up with an organized list. So right now I'm going to create a list of the number pairs that multiply to 15. If you do this in an organized fashion, it's going to keep your life a lot easier. So I start with the smallest number, 1 and 15. And then if I were to go up to 2, I would realize that 15 isn't divisible by 2. So then I go up to 3, and I get 3 and 5. If I were to go up to 4, I would realize that 15 wasn't divisible by 4. And then finally, I'd start looping back around. If I got back to 5, I would just write 5 and 3 again. So this is a complete list of number pairs that multiply to 15. So we're looking for a pair of numbers that multiply to 15 and add to your B term. So 1 plus 15, that equals 16. So that's no good. We're looking for pairs that add up to 8. So thankfully, this pair works, multiplies to 15, adds up to 8. So these two magic numbers, as I call them, go into the blank spaces in your parentheses. All right, so since it's positive 3, it's x plus 3. And since it's positive 5, it's x plus 5. Hopefully one of the things you're always asking yourself in math is, how can I check my work? So hopefully you're asking that now. How can we check that this is the correct answer? How can we make sure that we factored correctly? By distributing. So distributing, some of you might know the acronym FOIL, is the inverse of factoring. So if this is our factored answer, if we wanted to double check that we've done this correctly, we could undo all of our hard work by foiling or distributing and make sure that it brought us back to this original trinomial. If it brought us back to the original trinomial, we would know that we'd done it right. So let me show you what I mean. The acronym FOIL, a lot of you are probably familiar with. At first I multiply the first term, so x times x gives me x squared. And then if I distribute this x to that 5, I get plus 5x. So far I've distributed this x to both of the terms in the second set of parentheses. And now I'm going to do the same thing with the 3. So if I distribute the 3 to the x, I get 3x. And if I distribute the 3 to the 5, I get 15. Your last step would be to combine like terms. These two terms in the middle are like terms and therefore combinable. If we add them, we get plus 8x. This quadratic trinomial should look really familiar. It's what we started with. So in doing this process right here, we undid the factoring, but we confirmed that it was correct. All right, so this is totally extra. This is like if you have extra time on a test or you're being really careful on a homework assignment, you can double check your answers by foiling or distributing. Not crucial, just a double check. This would be your final answer. This is the factored form of this quadratic trinomial. All right, let's practice a couple more because it gets harder with negatives. So I'm going to work through example 1 very slowly, and then 2 and 3 I'll do a little bit quicker. So for that first one, once again, I set up my parentheses with 2 blank spaces. I'm going to find the magic numbers and put them in these blank spaces. So remember, the magic numbers are numbers that multiply to negative 63 and add to your B term, which in this case is negative 2. Like I said, this gets a lot more difficult when you're dealing with negatives. So I'm going to kind of walk through how I deal with negatives. It's similar to what I talked about on the last slide, but with some additional difficulties. So I start by making a list of numbers that actually multiply to positive 63. So for the moment, I'm going to ignore the fact that this is negative 63, and I'm going to make a list of number pairs that multiply to 63. I'm going to do this in an organized fashion, starting with the smallest numbers. 1 and 63, 3 and 21, 7 and 9. And that's it. And I just did that on my calculator, right? I kept it nice and organized. I started with the lowest number and then I went up to 7. If I were to keep going, I would start looping back around to 9 and it would be repetitive. So this is a complete list. But now we have to think, wait a second, these numbers are actually supposed to multiply to negative 63. The only way we can get them to multiply together to be a negative is if one number per pair is negative. All right, because positive times negative is negative. So one number per pair has to be negative. The question for you is, should it be the smaller number per pair or the bigger number per pair? Well, if the two numbers have to add to give us a negative, that means it's going to be the bigger number per pair that's made negative. So let me show you what I did. I made all my biggest numbers per pair negative. And now I'm going to test. I'm going to add these up. 1 plus negative 63 is negative 62, so that's no good. 3 plus negative 21, that's negative 18, so that's no good. The last one, 7 plus negative 9, is negative 2, which is exactly what I was hoping for here. So those are my quote unquote magic numbers. You put them in the parentheses and you're done. All right, if you wanted to check your answer, I would highly encourage you to multiply these two binomials back together just to make sure it brings you back to the original question, but you don't have to. It's just a smart way to double check your work. I'm going to go through, like I said, example 2 and 3 a little bit faster, and I'm going to skip some steps, but you should probably still be doing out those steps as you get into these good habits. So I set up my parentheses, and then I'm going to skip actually making the list of number pairs. But if you don't just come up with the pairs on your own, you want to be making an organized list to keep your work organized. Sometimes you're just going to be able to think of what the numbers are. Two numbers that multiply to negative 20 but add to 8 are 10 and negative 2. And for the record, it doesn't matter what order I put these in. If I put the negative 2 over here and the plus 10 here, that's totally fine. It doesn't make a difference. Last ones, so I start with my parentheses. I'm looking for two numbers that multiply to positive 6 and add to negative 2. This is actually quite tricky. In order for two numbers to multiply to a positive but add to a negative, they need to both be negative. So let's just confirm that these two magic numbers are correct. Negative 3 times negative 2, negative times negative, does give us positive 6, check. And negative 3 plus negative 2 does give us negative 5. All right, so that one's kind of tricky. They're both negative. All right, let's talk about kind of easy quadratic trinomials and how to factor them. So at first glance, you would look at this and say, oh, shoot, we have a 2 in front of the x squared term. This is not an easy quadratic. But let's go up here to these two steps, and we'll see that it actually is an easy to factor quadratic kind of in disguise. So step 1, pull out a greatest common factor. If you're looking at these three numbers, do they have a greatest common factor? Do they have something that divides evenly into all of them? They do, it's 2. So I'm going to pull out that greatest common factor, which means that 2 goes on the outside of the parentheses. And then each of these terms gets divided by 2, leaving me with, right, 2x squared divided by 2 gives me x squared. 14x divided by 2 gives me 7x. And then 20 divided by 2 gives me 10. All right. And if you wanted to confirm that you did that right, you could distribute this 2 back inside the parentheses, it would bring you back to the original. Either way, you'll notice that inside the parentheses, we are left with an easy to factor trinomial, right? Originally, we had this annoying 2 here, but now that I've pulled out that greatest common factor, the quadratic that I'm left with inside the parentheses is easy. You do still have to keep factoring it though. So this factors into x plus 5, x plus 2, and then I can't forget about this 2 that I pulled out in the very first step, right? That still goes down here. All right, but this is correct because 5 times 2 multiplies to 10, and 5 plus 2 adds to 7. All right, so this would be your final answer. All right, so this is a kind of easy quadratic trinomial. Originally, it looks like it might be hard because of this coefficient, but then you can just get rid of that coefficient by dividing all the terms by 2. These are the harder quadratic trinomials to factor. These might be an overwhelming steps to read at first, but I'm going to go through them one by one, talking about this example. So let me start off by refreshing your memory. What makes this a hard quadratic trinomial to factor? It's this 3, right? Because we have a coefficient that's not 1, this is a harder to factor quadratic trinomial. And the last problem, we could get rid of this coefficient by dividing all the terms by 3. But we can't do that in this problem because 11 is not divisible by 3, and neither is 10. All right, so step 1, look for a greatest common factor and pull one out if there is one. There is no greatest common factor. There's nothing that divides 3, 11, and 10. So step 1 is already done in this example. Step 2, multiply your A term and C together. And in case you're not familiar with what I mean about A term and C term, this is your A term, this is your B term, this is your C term. So step 1 or step 2, multiply your A term and your C term together. If you do that, you should get negative 30. Step 3, we're still finding magic numbers, but for harder trinomials, the magic numbers multiply to this. So they multiply to 30 and still add to your B term. All right, so they no longer multiply to 10. Rather, they multiply to 30 and add to your B term. I'm going to kind of skip the process of making a complete list of the number pairs that multiply to 30 because I can sometimes just come up with the pairs in my head without going through the process of making that list. If you can do that, great. If you need to make the organized list, that's great too. The correct magic numbers are 5 and 6. Pause with me and confirm that they work. 5 times 6 is indeed 30, and 5 plus 6 does add to 11. So they are magic numbers that work. Step 4, split the middle term. What the heck does that mean? That means I am rewriting this middle term. I'm breaking it into these two terms. Let me show you what I mean. So I broke 11x into 5x plus 6x. So you break up this middle term according to your magic numbers. All right, it's kind of like the opposite of combining like terms, right? We split this middle term into 2 like terms. All right, this is frequently called splitting the middle term. Next, we're going to pair up the first 2 numbers and, the first 2 terms and the second 2 terms using parentheses. Step 5 says factor the greatest common factor out of the first pair and the second pair. So I'm going to look at each of these pairs separately and pull out the greatest common factor. So just looking at these two, if we look at 3 and 5, they don't have a greatest common factor besides 1. But what these 2 terms do have in common is an x. So if I pull an x out of both of those terms, aka divide both terms by x, here's the x that I pulled out, and then inside the parentheses I'm left with 3x plus 5. The second set of parentheses is a little bit more interesting. Their greatest common factor is just 2, right? Because 6 and 10 are both divisible by 2. We cannot pull an x out of the second set of parentheses because this term doesn't have an x. We're looking for a greatest common factor. So we can only pull a 2 out of that second set of parentheses. If we divide 6x by 2, we get 3x. If we divide 10 by 2, we get 5. All right, and once again, if you wanted to confirm that you did that right, distribute this x back inside the parentheses. Make sure it would bring you back to what we started with. Distribute this 2 back inside the parentheses. Make sure it would bring you back to what we started with. You might notice that these two sets of parentheses now match. That will always be the case. If you have done your work correctly, these parentheses will always match. If they don't, it means you've made a mistake. So that's kind of a good way of being confident that you're correct. If the parentheses match, you're in good shape. If they don't match, you know you have to go back and try and find your mistake. This next step is the most confusing one to explain in words. So I kind of just vaguely wrote write final factored answer. But listen closely to how we move from this step to our final factored answer. These two sets of parentheses just become one set of parentheses. So the matching 3x plus 5, 3x plus 5, they just get written once. So 1 3x plus 5. And then I call them floating numbers. These two floating numbers, the x and the plus 2, they get written in a single set of parentheses as well. So this would be our final answer. This is the final factored form of this quadratic trinomial. So one more time, let me repeat what I said. These two matching parentheses just become a single set of parentheses, and then the floating numbers get combined into a second set of parentheses. Once again, hopefully you're wondering, how can we check if we factored correctly? By distributing. So the same way that we've already checked our work a couple of times. If you distribute these 3x and then the 5, or you might know the acronym FOIL. If you distribute the 3x, you'll end up with 3x squared plus 6x. And then you distribute the 5 and you get 5x plus 10. And then if you were to combine these two like terms, you'd get 3x squared plus 11x plus 10, which looks familiar. It's our starting quadratic trinomial. So we know that we have done it correctly because we checked our answer and it brought us back to the original question. All right, so this is a lot of steps. You might want to rewind the video and watch me do that whole process one more time. I am going to do one more problem on the next slide. So the first step is to look for a greatest common factor, so something that goes into 2, 5, and 12. There is nothing. So that step's already done. Your next step is to multiply your A term and your C term. If you do that, you get negative 24. Our magic numbers are going to be two numbers that multiply to negative 24 and add to our B term, which is negative 5. Once again, I already know what the pair is, so I'm just going to kind of jump right to what the magic numbers are. But if you can't come up with them in your head without a little bit of thought, you should be making the organized list. All right, so 3 and negative 8 are the correct magic numbers. Let me reconfirm why. 3 times negative 8 is negative 24. And 3 plus negative 8 gives us our B term, negative 5. So we're going to split the middle term again. So this middle term gets broken up according to our magic numbers, 3x minus 8x. And I should say I put these in random order. If I had it flip-flopped, negative 8x plus 3x, it wouldn't matter. Before I put the parentheses around the first two terms and the second two terms, I have to rewrite this as plus negative 8x. All right, so originally it was just minus 8x. I've rewritten it as plus negative. When you add these parentheses, you need them to have addition between them. So the simple fix is just make it a plus negative 8x in this case. All right, so that's important. You do need addition between the parentheses, so sometimes you're going to have to add a plus negative. Let's go through this one step at a time. So first I'm looking at the greatest common factor of this first set of parentheses. And the only thing they have in common is an x. So if I pull an x out of both of those terms, if I divide both of those terms by x, it leaves me with 2x plus 3. And then I haven't discussed this next, what to do next. If they're both negative, you're actually pulling out a negative greatest common factor. So -8 and -12, the greatest common factor there is -4. So you can see I pulled out a -4, and this is what I get when I divide both of these by -4. -8x divided by -4 is 2x, and -12 divided by -4 is +3. Once again, you could check that you've done this correctly by distributing that -4 back into the parentheses. It would bring you back to this original set of parentheses. Yippee! The 2x plus 3 matches the 2x plus 3 there. That's a really good indication that I'm doing this correctly so far. Last step, combine the two floating numbers in a single set of parentheses. And then these two matching parentheses just become a single set of parentheses. And that is my final answer. This is the factored form of the original trinomial that I was given. All right, so hopefully that makes sense. You can see that the harder quadratic trinomials have quite a bit more steps. I want to just summarize everything that I've talked about in this video in one kind of flow chart. So this is how you factor quadratic trinomials. Your first step should be to pull out the greatest common factor if there is one. Next step, is the coefficient in front of the x squared term 1 or some other number? If it's 1, your life is awesome. It's way easier and way quicker to factor if that leading coefficient is 1. You just set up your parentheses like this, and you insert the magic numbers into these blank spaces. If it's some other number besides 1, and this is the process that I just went over, so hopefully it's familiar, you have to find the magic numbers, which multiply to a times c and add to b. If this new phrasing is confusing, just go back and rewatch the video where I originally explained this. And then you split the middle term, and then you group the first two terms and the second two terms, and you factor out the greatest common factor. Once again, this process summarized in this bubble is what I just talked about on this slide here. Okay? So this summarizes, let me go back, kind of like a flow chart that summarizes how to factor any quadratic trinomial. Hopefully you found this video a helpful summary of factoring quadratic trinomials.